There you go. Let's underline adjacent angles. And let's see what they are versus what they aren't. I want you to highlight angle 1. And then highlight angle 2. Let's see everything about them. Are they right next to each other? Yeah? I want you to give me 3 bullet points. Both of these two angles share a common vertex. Do we agree on that? Yeah. We have a common vertex. And then it's also sharing something. It is sharing a common ray. So we have a common ray. And is angle 1 and angle 2 right on top of each other partially? Or are they its own? They're next to each other, right? So we know they're not overlapping. So I'm going to say they're not inside. Because I want to see one that is inside. On the second row, I want you to highlight angle 1 on the third image. Again, I'm not looking at all of them. And then now look at the angle ABC. This right here. It is sharing a common ray on the outside. It's got a common vertex, but it's all of angle 1 inside of angle 2. So it must not be inside, so that's not adjacent. So let's underline not adjacent. So I gave you one that is and one that isn't. Are we clear on that? If you want to analyze more the rest of them, you can, but then we're going to move on. Let's go ahead and underline vertical angles. And I'm going to model something up here. This is a good one. Okay. This is my workout. Y'all ready? So here's line 1. Yes? Here's line 2. And I want you to only focus on the top and the bottom. As I open the top, what happens to the bottom? It also opens. As I close the top, what happens to the bottom? So the bottom line is vertical angles are always congruent too. So let's go ahead and highlight line 1 and line 2. So we know our vertical angles are always congruent. So these two are congruent and the other two are congruent to each other. Are we all good on that? Yeah, I think I've seen this drawing somewhere before. Do I have room? Maybe right here. I have seen someone say vertical, as in top looks like a V. Angles are always congruent too. Do y'all see the V and the A? If you see it, good. If you can, that's fine. But vertical angles, I think I kind of see it from that. Now look at the ones, let's look at the one that is not vertical. And I want to mainly look at the middle figure. Why is angle 5 and 6 not vertical? Let's talk to your neighbor. Say, hey neighbor, why is it? Do you know? All right, Dustin, why is it not a vertical angle? It doesn't go vertical. Okay, because it's not, right? Okay, let's go ahead and define this and let's see why that is not. So vertical angles basically is given two intersecting lines, two non-adjacent angles are congruent. So the bottom line is the middle one that is not a vertical angle, I don't have two straight lines. Ooh, y'all can't see, there you go. Given two intersecting lines are the key, two intersecting lines. I gave you some random angle and a random angle. So therefore, they're not vertical angles. It's gotta be a line 1, line 2, boom. So I'll read it again since my handwriting is awesome. Given two intersecting lines, two non-adjacent angles are congruent. So let's define one more and we'll apply them. So if you're ready, give me a thumbs up. Two non-adjacent angles are congruent. I think my ugly handwriting is kicking in. On day number 6. All right, let's go ahead and underline linear pair. Within the word linear, I want to highlight the word line. Line. So if I have a linear pair, I better see a straight line. Let's see if that's the case on my first example. Let's highlight angle CEA. And now highlight angle AED. If I add these two angles, does it make a straight line? Yes? So we have a linear pair. So let's define everything about linear pair. First of all, are they next to each other? Are they side by side? Okay, adjacent. And secondly, it must add up to how many? What's a fancy word for 180? Starting with the letter S.
Straight.
Okay, straight angle. I like that. What else? SU. P. Complement and supplement. Thank you. They're supplementary. If you're like, whoa, that's kind of new, maybe it also means it's a straight angle. And if you want to say, hey, that also means 180, works out as well. So let's see one that is not. And I want to look at the last one. Highlight angle 30. Highlight angle 150. From the two bullet points that I gave you, which one does it not satisfy? They're not adjacent, they're just floating up in the air, and they have to be connected together. Okay? All right. So let's see. Daniel, let's read the instruction on example number 1.
Tell whether the angles are only adjacent and form of a linear pair or not adjacent.
I think the bottom line is I want you to tell me, is it adjacent? If it's a linear pair, it's going to be adjacent anyway, so linear pair or not adjacent. So partner up, go.
Okay, 5 and 8.
All right, let's go over it. If your neighbor's talking, tell them hush. Very good. All right, because we have 3 individual questions, are we okay with me not highlighting? Because then one's going to affect the other. All right, angle 5 and 6. So here's angle 5, here's angle 6. Okay, it's adjacent, but specifically, what is it doing together? They're making a linear pair, because linear pair automatically means it has to be adjacent. We don't have to be redundant. Linear pair. And then we have angle 7 and angle SPU. So here's our angle 7. Here's angle SPU. Are we allowed to have an angle inside another angle?
No.
So this one's going to be none. What about 5 and 8? 5 and 8 is created by line 1 and line 2, and they're non-adjacent opposite angles, right? So they're called? They're vertical angles. So for this one, it says the vertical angle is not part of it. Let's just write out vertical angle. The instruction should have said vertical angle as one of them as well. Vertical angles. I guess we're being more specific. If you said none, you are answering the question correctly. But let's make it more specific and write out vertical. Did I spell vertical correctly? Vertical. Okay. All right, next portion, Nash. Let's read example number 2.
Find the measure of the complement of angle E.
Okay, on angle E, did I give you an actual measurement? No, I didn't. So that means your complement will also have an x. So let's kind of think about what complement means. Angle 1 plus angle 2 has to equal how many?
180.
180. But since I have one of them, not 180, complement is 90. Let's underline this as a reminder. So if I already have one as an expression, can I take 90 minus that angle? Yeah? So let's say 90 minus, and here's a key concept. You must put in parentheses because all the component in the inside must be opposite because a minus means distribution of a negative. So when I distribute, we get 90 minus 7x plus 12. And like I said, it's going to be in terms of x. What is 90 plus 12? 102 minus 7x. And that is going to be its complement. So here's my question to you. We said the two smaller angles together has to be 90, right? So here's one small angle. Here's the other two small angles. Let's add them up. If I take these two and add them up, what do I actually get? 90. Okay? That's another way to look at it. So if you want to write that out off on the side, add those two up, will be 90. Do it. If you want to set the actual expression, go for it as well. All right. Junior, let's read number 3, please.
An angle measured 3 degrees less than twice the measure of it behind the measure of it.
Complement. So we know two angles when I add has to be how many? 90. So the way I'm going to write this is going to be more of a visual. Something plus another something must be 90. And the only expression given to us is 3 degrees less than twice the measure of its complement. So that means its complement is going to be x. We've got to start somewhere. So going back to algebra 1, using the variable x, how can I represent 3 less than twice the x? 3 less than twice the x. 3 minus 2x or 2x minus 3? 2x minus 3. When there's a word less than, that means the value before has to go at the end. So now let's go ahead and combine like terms. We have 3x minus 3 must be 90. And then 3x must be 93. How many is my x then? 93 divided by 3. 31. So let's see what it's asking us. The complement was the x. Its complement. So find the measure of its complement. We have the x, so we're done. Okay, if you're ready for the last page, give me a thumbs up. Ready for the last page. Okay. So I'm going to model number 4, and y'all notice number 4 is somewhat similar to number 5 maybe. Okay? So Maggie, let's read number 4.
The ratio of the measures of two complementary angles is 1 to 2. What is the measure of the one?
So the word ratio basically means we have the same variable. I want you to write same variable at all times. So that means on this one, instead of 1 to 2, I'm going to say 1x to 2x. Because unless we have a variable, we can't solve for that value. And we know they're complement. So I could take 1x plus 2x equal to how many? 90, very good, because complement is 90 degrees. So 3x must be 90. So x must be how many? 30. So we're going to automatically pick A, right? And feel good about it. Are we good with that one? It says find the measure of the larger one. So if I have x is 30, this one is 30, but 2 times the x, which is 30, is going to give us 60. So we know this is not a good answer. It'll be that one. So be really careful. And this happens on the SAT and ACT a lot. You get the answer and you see it. And we get excited. Everyone good on that? Okay? With the partner, let's try example number 5. Go. Are we happy with the answer that I circled? What did it ask us to find? Smaller one. So we know if it's supplement, it's got to be, if it's 105, the other one has to be 75, so this is a better answer. So I'm just showing you, we all make silly mistakes, but we do have to read the question in the end. Any questions on that? Do I need to show this one? We can all add, equal to 180? Okay. But then the last portion, we're going to actually, some of them we might name and some of them we might not. If you see M as in measure in front, that means it is a number. So measurement is a number. And that was on the last notes, I believe. So let's see. If I know that's 40 degrees and this angle right here is 90 degrees, do I see a vertical angle anywhere? Here to here? Do we see a vertical angle? So if this is 40, and angle 1 plus angle 2 must be 90, angle 2 must be 50. And then let's go further. If I know I have a linear pair, and I know one of them is 40, the other must be 140. And then what must be this angle then? 90? Okay, let's fill it in. Angle 1 is 40. Angle 2 is 50. BEA, so BEA is 90. DEF is 140. And then BEF is this together. How many would that be? 130, very good. So now we're done with the measurement, the values. The next piece says name them. So when you're naming them, you don't put the M in front. So there's many, many pairs of adjacent angles. So I'm not going to list every one of them. Okay? So with the partner, I want you guys to decide which adjacent angles do you want to look at. There's many answers. So if you disagree with your partner, it is okay. But I'm only gonna name one of them in a little bit.
What do adjacent angles like have to be Oh no, because they have to be
You can see it. B, C, and C.
Yeah. It's 180. And
30 seconds.
Oh, the data one is
D, E, F, and then F, E, something for the ankles
So what I put down will not be the only answer, so if you're convinced with your answer, do not erase it. So we have many, many adjacent angles. Could I say angle 1 and angle 2 are next to each other? Sharing a common vertex with a common ray? So I'm gonna say angle 1 and angle 2. Doesn't mean that is the only one, but I can't list every one of them. Okay? We're kind of lacking time right now. Complementary simply means when I add two things must be 90. So if you chose 50 and 40, or 50 and this 40, it doesn't matter. Complement does not have to be adjacent. So use any that you want. Just to kind of differentiate it, I think I'm going to say angle 2 and angle AEF. Complement simply means two angles that add up to 90. Supplement means they add up to how many? 180. Which one could it be? It could be these two or these two, right? So how about angle, did y'all pick maybe AEF and DEF? And DEF? If you saw angle 1 and DEF, that's fine too. It looks like that is also our linear pair, but just to differentiate it, I'm going to pick a different one. Angle 1 and angle DEF is linear pair. And then the last one, vertical angles, there was only one that was congruent to, right, on this one? Although, I could also say the 50 and 90 is vertical to 140. Let's get creative. Let's do that one. Angle CEA and angle DEF are vertical angles. If you chose the one with the 40, that's fine.